Welcome to another IB Mathematics video. In this one I'm going to be talking about the dispersion measures. You might have heard about these. These are the range, the quartiles, the interquartile range, and the most famous one, which is the standard deviation or the variance. You've probably heard about them, and all you know is that you don't understand what they are. Well, we're going to try to revise the whole thing. And please remember to ask if you don't understand what it is, because it really is not that hard. So to understand why we have to deal with dispersion measures, we're going to start talking about the problem with outliers. So what are outliers? Outliers are numbers that are much bigger or much smaller than the rest. For example, here we have 587. And here we have, a lot of numbers which are roughly around the middle, and then we have 24 and 21. They're not quite as exaggerated as outliers, but again, we can see that, hey, these are a little bit more than the rest. This is a very exaggerated example, 511 here. You can see how it really affects our central measure, our measures of central tendency, because the mean here is much bigger than the median or the mode. And in the other cases, things have also been severely affected. So in a way, it's hard to really see how important the outliers are and how much they're affecting our data. And for that, we have dispersion measures. They're going to give us a very, very straightforward information of what's going on with the data, and whether we have some severe outliers that are really changing the central tendency measures around. So, the most basic one is the range. And what the range, the only thing it does is it gets the maximum number, gets the minimum number, and subtracts it. So, for example, for this one here, the range is going to be 587 minus 1, 586. Simple as that. It is a very easy dispersion measure to use, but it has not that much information, because we don't really know whether it's a problem of just one outlier. There are many outliers. Outliers are in general a problem. What's going on exactly? It's a good quick way to get the information, but not that great. Slightly better are the quartiles, and you use the quartiles a lot in statistics just because they're easy to calculate, very visual. They give you a good idea of what's going on, and we're going to be using them a lot in graphs. You'll see it later. So what happens with the quartiles? Well, what happens with the quartiles is they're just the median of the halves. So you have this set of data here, so you cut it in half. Simple as that. If it's an odd number of numbers, then we're going to have one that's right in the middle, and we're going to have two equal halves with the same number of values. This one has 1, 2, 3, 4, 5, 6, 7, and this one has 1, 2, 3, 4, 5, 6, 7. Okay, so once you've done the first division, where you divide it in two equal parts, all you have to do is take the median of each half. This one here, the ones in the middle. Here's another example. Remember, when you calculate medians or you calculate quartiles, everything must be in order. This is a very useful one, and we're going to be using and seeing this one quite a lot. Typical exam question, you will see it for sure. The interquartile range, the only thing you do, similarly to the range, is instead of taking the maximum value and the minimum value, you do the same operation that you do with the third quartile, the one at the top, minus the other one, minus the one in the beginning. And that's going to give you the interquartile range. Just a little note here, sometimes you will see Q2, and that will actually be the median, because here you have Q1, here's Q3, well, in the middle it's going to be Q2. And that's going to be the same thing as the median. So here's a typical exam question, where they give you a big set of data, and it asks you to calculate the interquartile range of the following data. Now, the most common mistake, as I always say, is people forget to put it in the correct order, so you have to take your time and do that. Then you will have to divide it into equal sections, and then you will calculate the median of each half. Not that hard. When you calculate the median of these two halves, what happens is that because you have 6 elements in each half, to calculate the median, you're going to have to calculate the mean of the two in the middle. So it's going to be 109 plus 112 equals divided by 2. It's going to be 110.5. So remember, the median of 6 elements is going to be the mean of the 2 elements in the middle. Once we have calculated the quartiles, we just calculate the interquartile range. That's the simple. So what about the famous ones, the standard deviation and the variance? Well, the good thing about the standard deviation and the variance is that they give us all the information we need. It takes all the values into account. It really is the perfect dispersion measure. You might have it, it's also its disadvantages, but in general, this is the one that really is going to tell you what's going on exactly. The thing is, it depends on the level you're doing mathematics at. You're going to be required to do this with the calculator or not. As for this presentation, we're just going to be looking at it as if we're going to be doing it with a calculator. When you're doing it with a calculator, the very important to take into account is that these two are different standard deviations. And let's remember now, when we looked at types of data, what it meant to do when we had the whole population and what it meant when we had a sample. In these cases, in the cases in which we have a sample, in the calculator we're going to be looking for the value with the S. And in the cases where we have all the population, it's been taken into consideration, then we're going to be looking for the sigma, the Greek letter sigma. And that's it. We're just going to be introducing the data. We're going to be telling our GDC to calculate the standard deviation, and we have to remember to pick the right one. The variance is just going to be this one squared. So not very hard. But it's important to remember that in that definition, because in real life, in real statistical studies, you will find people talking about the variance and people talking about the standard deviation. There's different reasons for that, but that's not part of your concern right now. What you have to remember is the variance is the standard deviation squared. End of story. And here are a few examples on how to do it. So go ahead, get your calculator and see if you can figure out how to get this data right. This would be the solutions. Here's a typical exam question. Very similar to one we've seen before. You get a set of data, it's in the correct order, and you're told what the interquartile range is. And you have to calculate the value of x. It's not very difficult. And again, we have another standard deviation example. I encourage that you try it with your GDC and see if you can get it right. Beware for this one, when you calculate the standard deviation, it tells us the complete set of data. So we're going to be looking for sigma. Remember. So, to sum it all up, how do we calculate dispersion? Well, if we have to calculate the range, we find the maximum, the minimum. If we have to and subtract for the quartiles, we have to order the data, divide it into 2 equal sections, and find the median of each section. For the interquartile range, you just find the quartiles and make the subtraction. And these two, you just need to use your calculator for it. But I can't insist enough on the importance and the difference between sample and population. We'll be saying more about this later, but as for now, that really is all the dispersion measures you're really going to effectively need. So, thank you very much for watching, and I'll see you later. Bye-bye.